Hey everyone, welcome back to the virtual boot camp where for now we're going to walk through C++ from the beginning all the way up to where through examples we'll be able to demonstrate a few different techniques. If you like this video series, feel free to like, subscribe so you can get access to more content. And if you'd like, leave comments so that I know what you guys want to know, what you want to learn, what doesn't make sense, things like that. So let's get started. I already have some stuff here, so I'm going to get rid of it. I want to also take the approach where we start from nothing, where it makes sense, at least so you get the fundamentals down, and then we can start to use a building block approach to make things that increase in complexity as time goes on. So today, what I want to do is talk about functions, and I want to start at the beginning. So let's make use of, this is Visual Studio, by the way, but let's make use of the comment. It is a somewhat underestimated feature of Visual Studio. And my Visual Studio is Visual Studio 2020. Wait, I think, yeah, it's one of the latest, so don't quote me on the version. But for a definition of what is a function is like what you remember from math, where you got some input, you get some output. In C++ in particular, you have functions that take some type, that return some type, that have some name, and then have optional parameters. And then that have some body. And the body is where all the magic happens. So with C++, you have the main function, and that is the entry point that the compiler is going to use to execute your code. So if we start at the most basic place, or actually if we just start at the beginning, not basic, if I created a function called capital M main, what I'm saying to the compiler is the type is void, the return type is void, so it's not expecting me to try to return anything out of the function. The name of the function is main with a capital M, of course, and it does not take parameters. So if we compile this, will it run? I'll let you think about it for a second. And actually, the answer's down here. The answer is at the bottom, so no, it will not run. And let me save this and then build it, and then we'll see what happens. So when I try to rebuild it and create an executable, you get an error. And this is a linker error, not a compiler error. The difference between the two is the compiler is checking syntax and use. The linker is checking definitions. And in Windows, so C++ on Windows, there's a runtime library that is literally expecting a function called little m main, so that it can start to execute the code in our project. And like you see below, without that definition, it's going to give you an error. So that's just something to be mindful of. And it's important because if you're building executables and you do not have main, it will not compile. And you will get a linker error that looks like the one below. And these might look scary at first, but once you see them enough, it becomes more natural to think about what it's actually telling you, and is it a compiler error or is it a linker error? And the code is not being executed. So in this case, it's a linker error with a definition that the linker needs to create the executable. So now that we've got our main, little m, we should be able to do a rebuild, and it ought to just work. No errors. But you do get this warning. And the warning is basically saying the function main normally returns an integer, not void. And that's important because when you actually execute a program in Windows, in Mac, Linux, whatever have you, you'll notice that there are graphical programs and then there are programs that are not graphical. And in our case, so the non-graphical programs are called console apps, right? Because they run at the system level. They run in command doc, like the command prompt or PowerShell or Windows Subsystem for Linux on Windows. And then in Linux, they are executables, but they're in a different format. And on Mac, same thing. They're executables, but they're in a different format. These are the kinds of applications that are like system tools, like Top, Free, you can consider things like ls or dir or your vim or anything that's going to run in a command line. That's the kind of application that we're working with now. So these are not graphical, and because they're not graphical and it's C++, it's expecting main. To make a long story short. So one fundamental thing to remember is C++ requires a defined main function. And the signature of that main function is not void, it is int. And I'm sorry, I meant to complete the thought. So it's int, and you see it's giving another error now. Now that we've changed the return type, and actually let me say return type up here. We said we're going to return an integer, and we haven't returned an actual integer. So you fix that by just saying return. And remember, again, we're talking about functions. So a function, just like in math, you're going to give it some input, it's going to give you some output. The output here is the return. Actually, I'm sorry, the output here has a return type, and that's what you specify here. In the body of your function, though, you need to use the return statement to return a value from your function that is this type. So that's another thing to think about. And also, as convention, meaning this is the expected way to define the main function. You're going to give it something called argc, which is of type integer, and this is the count of arguments that are provided to your function. And then we've got this somewhat intimidating looking definition that is called argv. And again, by convention, this parameter is called argc, this parameter is called argv, and then the order in which they're defined does matter. So let's talk a little bit more about what argv is. Now, we talked about the int type, and we talked about the int return type, but there are a few other base types. So if we talk about the base types, we've got the int, which is usually for your numbers that don't have decimal places. We've got the float, and the float is a number, but it has decimal places. Another thing to just take note of is floats are actually doubles, and doubles are, in terms of their size as a type, they're larger than floats. So the system does what's called a truncation or a conversion from your double type to your float type. And you don't really have to worry about that if you're not dealing with numbers with decimals and accuracy and things like that. So let's keep going. We've also got the char type. Actually, let me line these up so they're easier to see. So, let me, all right. So your char type is it's a character, which is a single letter in single quotes. So it has to look like this to be a character. And let's see, we've got bool. So bool is our Boolean type. So think about true or false, literally true or false. And another thing to know about these is they really mean 1 or 0 in binary. But we will not touch on that yet. I just want to set the stage for what functions are, how they operate, and the types that they can deal with. But okay, so now that we've got the basic types, we need to, let's talk about collections of those types. And anyone that's used another language like Java or, I don't know, C# or, let's see, Go, maybe even Rust. Anyways, the point is collections are usually defined with the brackets, and they also are usually the same type. So if you've got an array of integers or an array of booleans or an array of characters, that's what I mean by collections. And in C++, collections are arrays when they are, for now. There are higher level collections that are have been written and are available as different libraries, but for now we're just talking about the basic types and the basic arrays and arrays/collections. So let's write this as that. So we're really talking about arrays of things. And the reason we're talking about this is because argv is an array of star char, which really means pointers to characters. So at a high level, and we'll dig into this in later videos, pointers are references. References to types. Now if you're using Visual Studio, let's do two things. You'll notice at the top of my my window, my application GUI, my IDE, that I am using the debug configuration. This just means it's 64-bit. Don't worry too much about that. We will definitely talk about that in later videos. Make sure that you've got debug and make sure that you've got x64. If just make sure it says x64. If not, then it could say x86. I am on a machine that's 64-bit, so I'm using x64. And the short answer to why I'm doing that is I want to make sure that I build an executable that matches my platform. So if you don't know what a platform is, that's really what we're talking about. It's going to be 32-bit, 64-bit, or some other, maybe I can't think of another platform. Oh, so it could be ARM based, if you've heard of that. So keeping a long story short, if you're on Windows and using Visual Studio and you know what your platform is, just set it accordingly here and then make sure that you're in debug. So the second thing is, let me save that. I am going to demonstrate what pointers are, only because I want you to at least be aware of them so that when we define functions and talk about code and things like that, that's not hanging over your head and you want to ask the question but you haven't. So, okay. And I also want to give examples so that you know what this actually is when we run the program. So what I'm going to do right now, because this function doesn't do anything, I am going to right click on my project, and I am going to, in the debugging window, I'm going to change so the command arguments, this option is connected to ArcV. And it's because Visual Studio is going to execute our program, and when it executes the program, it's going to go back into the debugger, and we'll be able to see how these command arguments that I'm about to put in are stored in ArcV, and we'll also see what argc is. So let's do that now. So if I wanted to run this program and I wanted it to just print the names that I'm putting here, okay, so I've added them. Let me apply. So what's going to happen is, whenever it's done thinking about it, it's going to provide these as input into my program. So now if I say debug, start debug, so the IDE launched our program in the terminal. And now, like I said, it's in the debug session. So if we look at our local variables, see right now it can't read anything because I haven't stepped in. So let me step in, and now we see we've got argc is 8, and argv has a bunch of these weird looking things. So these are all addresses in memory. So the thing about execution in Windows or any other operating system, it's all processes. And a process is just an executable, it's a thread of execution. That's the formal definition. But think about, if you're on Linux, if you're on Windows, if you're on your phone, all of the things that your phone or your desktop or your browser or your video game, everything that it's doing is probably in one or more threads of execution. And in order for the system to execute your thread, it needs memory. It needs memory that's static, or it needs memory that's dynamic. And the reason that main has these two parameters, argc and argv, is so that it can execute and use the parameters that the function has been given. So now let me expand this a bit. If we do a drop down on argv, we can see the first value here is C. So that doesn't really tell you much, right? But what we can do is we can say, let's see, we've got argv. The first value is really the name of the program. That's really what this is. So when I say that a pointer is a reference to a type, argv is an array, because we talked about collections and arrays. It's an array of pointers that, it's an array of references to strings, to arrays of characters. So the first value is the name of the program. So if we can also, so what I did was I went from the local view to the watch view. And in the watch view, we could say, okay, what is argv 0? Oh, yeah, and I tried to do that, but it didn't let me. So it is literally this string that I'm mousing over. So C, CPP Labs, Lab Project, XD4, debug, Lab Project, exe. So by convention, and remember we were talking about convention, your first value in your argv array is the name of the program that was executed. And the name of the program in Windows is the full path to the exe that was executed. So that's what argv0 is. The other thing to be mindful of is argc tells you how many parameters you've actually been given. The first parameter is the name of the program, and I mean that you've been given in argv. So these two together, argc will tell you how many parameters you have, and argv actually stores those parameters. And it's important for the main function because, like I said, main is the entry point or the first place that the runtime for the system is going to go to run your program. And that's true for any program. The only difference is if you're not talking about a console app, then there are a few other definitions for what's called the entry point that will give you a graphical program, that will give you a service that is not a program that you run directly. So if you think about looking at like the system logger on any operating system, or the memory profiler, those things can be services, and someone has to write them, and they look similar to what we did right now with our very simple main function, but they have different definitions and they use the parameters that are provided in a way that it's dependent on what they're trying to do. And as a developer, as a software engineer, that's really what writing code is all about. Even if it's a game engine or if it's an actual game, any of the different phases of the game loop, it's all functions. It's all code that takes some input, gives some output, reads things into memory, performs some operation. So let's keep looking at argv. So argv0, the value is the name of the program. argv1 is where we've got our first parameter, John. And again, the type is char star, which means a reference to a character string, where the character string is, like we said up here, it's a collection of characters. And if we continue to walk through our list here, we will see all of the names that we entered into the settings for our project. Right? And because there are only 8 of them, and these arrays start at 0, our last value is argv7, I'm sorry. So this is a very quick introduction to pointers, and I don't want to bog you down with the details of pointers just yet, but as a type that can be provided to the function, in particular here, the main function, it's important that you get a feel for what this means, what these are, how they work. And we will continue to do the same thing and just keep adding detail to it so that you get a much fuller and richer picture of, in C++, how functions work, how you define them, how you use them. And starting from here, though, you've got enough to make a very boring function, but actually do a little bit of debugging. So, okay, as one last exercise in this video, let's actually make this thing do something. So to get out of the debugging session in Visual Studio, you just have to hit the stop button. And you also want to be sure that you close your window that the IDE created when it ran your program. So, okay. Now we have a better idea of argc and argv. And again, you don't have to provide them, but if you do, then when you run your program from the command line, you can give it arguments and have those arguments do something useful. I won't get into that this video, but I think next video we'll actually use them to do something. But in the meantime, we can at least, let's do the following. I'm going to include IOStream. IOStream is a header, and we'll talk more about what headers are, but think of it as just a bunch of definitions. So someone else's definitions for types, functions, things like that, just to keep it simple for now. And I'm going to do a namespace standard using statement to, I want to use cout, cin, indel from the IOStream header. And I don't want to have to okay, let me see if I can explain this a bit better. I want to just say hello world. I can do that this way. Right? But the first thing that happens is the compiler gets mad and says, I don't know what this is. I don't know what this is. So then how do you fix that? Well, because we've got this included, we can just say standard like that. And it's important that you see I'm using 2 colons in both cases because I am using the namespace resolution operator to say which cout and which indel. Not that there are multiple definitions of them, but let's say you wanted to create your own versions of these operators or these definitions, but you had a different namespace. You can wrap the definitions in your namespace, and then what would happen is a conflict, because unless I say which namespace I'm talking about for the definitions that I want to use, the compiler doesn't know, and it'll give you errors because it wants you to be specific. See, the compiler is all about making sure that the syntax is right, making sure that the definitions are there, making sure that everything is accounted for, because when the linker comes along, the linker is just going to link all the different objects together, all the different binary encoded definitions, functions, whatever have you, and turn it into an executable. So syntax is much more important here. And getting back to the standard namespace, if I don't want to have to do that everywhere, that's why I say using namespace standard. Saying the namespace, as long as I don't have another include and as long as I don't have any reference conflicts because of the names, that's enough. It's enough to just say using namespace standard, and then it'll work like we expect. So this is the next. It's still trivial, but it's not useless as a function, if that makes sense. So let's set our breakpoint again and do a rebuild. And the reason I set the breakpoint even when it's just printing hello world is so that we can see what it's doing and not have to worry about it going by so fast or closing our console window. So if we just do this, it should work with no issue. And notice again, though, that because we've still got those parameters defined, they are still being provided to the main function. But, if we look at our console, it's just hello world, easy peasy. But okay, so we are beginning to talk about functions. And we talked a little bit about types and arrays or collections and a little bit about pointers. In the next video, we'll continue talking about functions because I want to define a few. I want you to get much more comfortable with basic type definitions for functions before we move on to more advanced things. So thanks again for watching. Hopefully it's useful. Feel free to follow along and let me know what works, what doesn't work. Feel free to attach questions or subscribe, and then you'll be able to keep going on this journey as we just talk about C++. It'll be some time before we switch to a different language, so I hope you guys keep showing up, and I'll talk to you again soon.